Okay, we're going to talk about heat loss and gain, which is really thermodynamics. And we're specifically talking about in buildings and losing heat and gaining heat in buildings. In Texas, we know the big concern is keeping it air conditioned and keeping it cool inside. But in most parts of the country, the bigger concern is what happens in the winter and how we can keep it hot inside. So as you go through this, you're going to need to take notes because there's going to be a knowledge check when you get done. So heat transfer, that's basically transfer means exchange, and heat, thermal energy. And temperature and pressure do have to do with it. Since we're talking about buildings being basically at sea level, pressure is relatively the same. So we're really just talking about the temperatures of outside. These are the three kinds we're going to talk about in this video. And remember that heat actually always flows from hot to cold. We learned that in physics and in POE, talking about heat goes from hot to cold. And the term thermal equilibrium means when everything is reached the same temperature. So here we have a little building, and in a building we might have it 70 degrees inside, and here we're talking about when it's cold outside, and basically the heat is all leaving the building. Some of it goes through each of these different parts, through the walls, through the roof, through the windows. Some of it will go through, there's always little gaps in the walls between the walls and the foundation. Some of it we lose through the windows itself. But then we also get energy coming in from the sun coming through the windows as well. Remember that thermal conduction is when we're talking about some piece of material where when it gets hot on one end, it heats it up on one end and the other end may stay cool. Think of like a skillet that has a metal handle. If you've ever been in the kitchen and you accidentally touch a metal handle, it'll be hot. Or if you've got a spoon in a pot, the handle of the spoon will get hot. Versus something that is insulated, insulation will keep it from getting hot. If you have a pot with a plastic handle or some kind of spoon or something that you stir with in a pot and it's got a plastic or wood handle on it, it doesn't transfer energy. I skipped one, sorry, there we go. Okay, convection. Convection is our second kind of heat transfer. And that has to do with when we're dealing with a fluid, and a fluid is either liquid or gas. And when the movement of the liquid or gas carries the heat with it. So in the case of houses, we're not talking about liquid usually filling the house. We're usually talking about gas, air, filling the house. So if the windows are open, the air can go through the windows and carry the heat with it. Remember, hot air is lighter, so it rises, and this is convection. And then radiant heat. Radiant heat or radiated heat is things that come off in energy waves or rays, and they're not particles. So we're talking about when you have a heater. Like this here, a heater like this is actually putting off heat particles. It's not blowing hot air, it's actually heating up the air here, and those are traveling in waves. So which modes of heat transfer can we see in each of these arrows? Well, anything that is going through a wall has to be conduction, because we're talking about it physically heating the material of the wall on the inside, and then this heats the next part of the material and so on going out. When we've got the sun heating the house through the window, that's got to be radiation. This window is shut, and so there's no way that the sun can heat up the inside except through thermal radiation. And finally, if the window is open, we could lose some through convection, or through the little cracks that are in the house, we could also lose it through convection, where the air temperature inside the air is physically moving outside and we're losing it. So remember, this is radiation if the window is shut, and it's just the transfer of the heat through radiation coming in, versus this would be if the window was open and the air inside is actually escaping. Okay, heat loss occurs in the winter when we turn the heat on to make it hotter, and we lose the heat from inside to the outside. Heat gain is in the summer when we're trying to cool the air inside and the heat keeps coming from the outside in. Heating system design. In order to be efficient, because we want to be efficient and save energy, we need to provide at least as much thermal energy as we're going to lose. And we want to have minimize heat loss. So we want to have high R values for our insulation. And we want to use windows and skylights with a lower U factor. And we're going to talk about what these two factors are when we start doing some calculations. And we want to minimize convections. We don't want to have a lot of little air leaks where our air can escape through little cracks. We also have to think about a cooling system, especially here in Texas. So again, we want to have good insulation, but some things to think about is not only do you have the sun outside heating up the house, but we also have the people inside. People produce a lot of heat. We'll do those calculations later this year, and you'll see that people produce a lot of heat. You've probably seen that in classrooms with a lot of people in it. It heats up pretty quick. Also, equipment like stoves, ovens, computers, coffee makers, those can all heat up things. And then the lights themselves often also give off heat. You've probably experienced these things before, and so we often use lighting like fluorescent lights that don't give off as much heat. And we need to think about how we can minimize this sort of thing causing problems in our buildings. BTUs are the units we use for heat. And that's the unit, it's actually British thermal unit. That's what a BTU is, and that's what we use in the US. And it's the amount of heat required to raise the temperature of 1 pound of water 1 degree Fahrenheit. And it's about the amount of energy produced by burning a match. Fahrenheit's what we use here. Most of the world uses Celsius. We use Fahrenheit here. In HVAC, we will talk about these later on. That's heating, ventilation, and air conditioning is HVAC. And then BTUs per hour is the way we measure how much heating power something has. 1 watt, which you might remember from electricity, is a unit of power, but it's also used in thermal power, and it's approximately 3.4 BTUs per hour. And 12,000 BTUs per hour is a ton in most North American air conditioning applications. So you'll see a ton also if you look at air conditioners in addition to BTUs per hour. These are the two factors. You do not need to copy these down. These are on your formula chart, and we are going to be looking at them when we do calculations. And this is again the formula that's going to be on your formula chart. You don't need to write this down, but please go look at your formula chart at the back of your book and make sure you can see where this is. All right, that's it.